Okay, so first one, whenever you're multiplying like bases, all you're going to do is you're going to add the exponents. Okay, a lot of you have done this before without even knowing. So if you do x times x, okay, hopefully everybody knows that that's x squared because you added 1 plus 1 to get the 2. Alright, so now, whenever you have what we'll call a power to a power, what do I do with those two exponents? You're going to multiply them. So just m times n. Or if you have two terms, so you have two bases to the power of something, does that m belong to the a, to the b, or to both? Both. Okay. So to give you an example, more like what you'll see, because obviously we're not going to see a lot of a, b, m, and n problems. Something like that. You need to know that that is going to give you 2 squared, which is 4, x squared. This is always going to be the property, unless I have the zero property, which is rare. This is usually the first thing I'm going to do in any problem where I'm simplifying. I'm going to get rid of the parentheses because those freak me out, and I want to get rid of them first, and it makes the problem easier. Okay. The zero exponent property. This needs to be the easiest one. Might be the easiest problem that we do all year in here. Anything to the power of 0 is always going to be what? 1. No matter what. I do not care if it's a to the power of 0. I do not care if it's 12,843 x to the 7th, y to the 7th, x to the 6th, y to the 7th, z to the negative 8th, all to the power of 0. That's going to be 1. It does not matter if it's to the power of 0, it is 1. Whatever all that is.
But the parentheses got bigger.
Okay.
You're doing a really good job.
Thank you, I appreciate it. So, next, dividing like bases. What am I going to do with those exponents? I'm going to subtract them. Remember, the majority of the time, your multiplication and your division rules are just going to be the opposites of each other. So whenever I multiplied like bases, I added my exponents. So common sense might tell you that if I'm dividing like bases, I'm going to subtract the exponents. Next, dividing with different bases. What does that m belong to? The a, the b, or both? Both. Okay, hopefully that's not, that's just like up here whenever we're talking about the power property. It's something in parentheses. If it's in parentheses, that exponent belongs to everything within that parentheses. So the negative exponent property. This might have been one that y'all did not talk about. I don't know. But you're going to have a lot of problems where whenever you're being asked to simplify something, or you're dealing with exponents, you do not want to have a negative exponent in your answer. Okay? So whenever we have one, we need to know how to get rid of it. Does anybody know how to get rid of that negative exponent? No. Okay. So how you do this, and if you're not zoned in here, zone in on me here. You got it? Okay. So all you do is you take the base that is being raised to a negative exponent, and only its base, and you put it in the denominator. And that exponent becomes positive. Or, if it's in the denominator, you move it to the numerator. So really all you're doing is you're moving it to the other part of the fraction. If it's not originally a fraction, make it 1. Okay, you'll have 1 over. You just move it to the other part of the fraction and it becomes positive. We have a to the negative n. It's the same thing as the one above, just with n instead of 1. So a quick example of this. If I have 2x to the negative second, what is being raised to a negative exponent? Just x. Okay. So I am going to move the negative exponent and its base down there. Okay? If it was this, what has a negative exponent? Both of them, right? Okay. So I go down to the bottom. I end up with that. And then I get rid of my parentheses. 2 squared is 4, and then I have x squared. Okay, and we're going to turn the page, and we're going to do a lot of this here in just a minute. Emily's excited about it, I can tell. Alright. So once you have that written down, go ahead and turn to the next page. And we're going to go through a couple of these together, and I'm going to let you take over, and I'll just be working behind you a little bit as you go through there. Okay, so looking at the first one. Again, if I ever have parentheses, I'm going to deal with that first. So what property, Ayla, what property is this going to be? Or you can just tell me what it's going to end up being.
It will be n over 9. I'm sorry, the exponent.
N to the power of 9. Okay. Power to a power. 3 times 3 is 9. Times, Ryan, that second term there. What part of that term has a negative exponent? Just the n, right? So that is going to be the only thing I'm going to put in the denominator. Now, do I have to put n to the first power? No. So now I've got that. Do not overcomplicate this. A lot of people like to do that. Just make that a fraction, and you're just going to multiply across. Okay? Multiply straight across, one fraction to the other. So that gives me 2n to the 9th over n. I'm dividing like bases. So Alexis, what do I do with the exponents? If I divide like bases, what do I need to do with those? Nope. Subtract them. 9 minus 1 is 8. Alright, looking at number 2. So I've got a squared. Does that, Joey, the exponent of 2, does that belong to the 2, to the v, or to both?
Both.
Both. So I've got 2 squared, which is 4. And then v squared times 2v squared. Okay, and this is, you've seen stuff like this many times, maybe with x instead of v, but 4 times 2 is going to give me 8. V squared times v squared is going to give me 4. Okay, so going to 3, I'm just going to deal with the numerator. Okay, and so Alexis, what am I going to do with all the coefficients first?
Multiply them.
Just multiply them. So 2 times 4 is 8, times 3 is 24. And then now I'm just going to deal with all the x's, and so if I'm multiplying all these terms, Michael, what am I going to do with all the exponents of x? Just going to add them. So 2 plus 2 plus 1 is 5. And I'm going to do the same thing with the y's. 4 plus 4 is 8. And then I've got the numerator down below. The denominator down below. So now I'm going to go through and I'm just going to divide everything. Okay, so I can reduce, or 24 divided by 3 is going to give me 8. Now, let's leave the x's because I want to talk about that negative 3 and I also got a 5 up top, so kind of what do I do there? So let's go ahead and leave that. And then I've got y to the 8th divided by y squared. Alright, which, Erica, what does that become? Y to the 6th. Whenever you do that, make sure you always put the result in the numerator. Whether it's positive or negative, you need to put it in the numerator. If it is after the subtraction, if it's then negative, then you'll move it down to the denominator and it becomes positive. Okay, so now I've got x to the 5th divided by x to the negative 3rd. So that becomes what? X to the 8th. Because I take 5 minus negative 3, which becomes 5 plus 3, which gives me 8. So I end up with 8 x to the 8th, y to the 6th. Now, a good thing about some of these properties is the order in which you do these, a lot of times it will not matter if you do it correctly. Okay? You may do it a completely different way than I do it, which is fine. So, let's say you looked at this and you saw that x to the negative 3 was negative. And you didn't do the division property, you did the negative property. So that tells me that I can take that x to the negative 3. I can move it up to the numerator. Now don't write this, just kind of follow along with me here. And that makes that a positive 3. And then now if I multiply those two, x to the 5th times x cubed, that's going to give me x to the 8th, which is what we got doing it that way. Okay, so two different ways. As long as you do it correctly, you're fine. I do not care which way you do it. Okay, walking through number 4. So, first thing I have is a power to a power. So I'm going to do x to the power of negative 12 times 2x to the 4th. Now I'm going to multiply, so what do I do with my exponents? Add them. Negative 12 plus 4 is going to give me negative 8. Does the 2, or the x, or does both have a negative exponent? Just the x. So all I move to the bottom is the negative exponent and its base. Now I get 2 over x to the 8th. Okay, so keep working on the rest, and I'll go over those here in a minute. Okay, going through 5. Let's look at 5 real quick, because I know it's throwing some people off. What is the only thing that turns into 1?
0.
Whatever is being raised to the power of 0. Okay, so jump down real quick. What's the answer to 8 going to be? 1. What's the answer to 5?
X. Just X.
It's going to be x over 4. Okay, now listen. The only thing that's going to turn to 1, it's not the whole denominator, because the whole denominator is not being raised to 0. The power of 0 is just kind of somewhere in there. So this right here, x to the power of 0 becomes 1. If it's within a problem like this, just kind of think about, alright, well that just cancels itself out. So I'm left with x over 2 squared, which turns into x over 4. Alright, real quick, let's jump to 9, because it's kind of simple. What's the answer to 9 going to be? X to the power of 4, y to the power of 3, because this whole thing becomes 1. And anything times 1 is itself. Alright, so if you haven't already, go ahead and walk through 6 and 7, along with 9 and 11, or 10 and 11, sorry. Alright, let's go through both 6 and 7. So, on 6, first thing I'm going to do, get rid of the exponents. So I've got 2 m to the negative 4th, which, yeah, the parentheses, sorry, which I might have lied to you. It's a small, okay. So that 3, that belongs to the 2 and the m to the negative 4th. So 2 cubed is going to give me 8.
What?
Okay? 2 times 2 is 6. Sorry, 2 times 2 is 4. Times 2 is 8. That's right. That's right. I'm your math teacher. So, all right, and then 3 times negative 4 is going to give me negative 12. So I'm going to subtract 4 minus negative 12, which becomes, sorry, negative 4 minus negative 12, which becomes negative 4 plus 12. And that is going to give me m to the 8th.
Oh no.
And I can reduce 2 over 8 to 1 over 4. Okay, I don't necessarily have to write that 1 there. So there it is. Okay, so let's look at it. This one can be a little bit easier. Now, this is one situation. Please pay attention. This is one situation where usually I do say, all right, let's get rid of the parentheses first. Unless it's being raised to negative 1. Okay? Because if this whole thing is being raised to negative 1, instead of doing the power to a power property, I'm going to do the negative exponent property. And so all of this is going to get moved down to the denominator. So I'm going to have 1 over 2m squared. Now I don't have to put parentheses into the power of 1. But now I'm going to multiply that by m squared, which was already down there. And that gives me 1 over 2m to the 4th. Okay, let's look at these two down here. These two are very, just kind of these ideas. These are very CBA-esque questions where you've got two terms with a bunch of variables and exponents like what we're dealing with. And then it applies kind of just a basic geometry formula. How do I find the area of a rectangle? Base times height. So I'm just going to multiply these two. Okay, so what do I do with the two coefficients? I multiply them. What do I do with the exponents of x and the exponents of y? I add them. So 4 plus 2 is 6. For my y's, 3 plus 1 is 4.
I'm a little bit confused. I thought you meant you add x and y.
No. I apologize.
I got it. No, it's
Add them separately.
Wait, we're the two.
Okay, so over here on 11, if I have the area and I have the length, how do I find the height?
You're supposed to divide them, I think.
You divide them.
Yep.
Please, especially early on, unless you are just extremely good at mental math, but if you're more visual, please write this off to the side. So what do I do with the 8 and the 4?
You divide them.
I divide them. What do I do with the exponents?
You subtract them.
I subtract. So 5 minus 2 is 3. 4 minus 3 is 1, so I just have y there. Alright? So, let's go to the next page here. So looking at this top table, I'm going to have a few of you put these into your calculator. So McKenna Wallace, will you put 4 to the 1/2? Joey, will you do 81? Lily, will you do 64? Sierra, will you do 100? And Jackson, will you do 25? If I did not say your name, I want you to pick one of those and do it, because you need to practice putting in rational exponents into your calculator. If your initials are up there, whenever you get your answer, please let me know what you got. Okay? Jackson? Okay. 8. Oh, that is. I got 2 JFs up there. Joy? Do what? No. No. Okay, so 81 to the power of 1/2 is 9. 25 to the power of 1/2 is 5. So, what conclusion can we draw from this, Matthew? Well, yes, but raising something to the power of 1/2 is the same as doing what, Alexis? Taking the square root. Okay, so on 2, I want you to put that in your own words. Okay, if you want to use the words that I said, that's fine. Raising a number to the power of 1/2 is the same as taking the square root of that number. Raising something to the power of 1/2 is the same as taking the square root of that number. On 3, 16 to the power of 1/2 is what? 4. 49 to the power of 1/2. 36. So if I can ask you what is the square root of perfect square and you can give me the answer, I should be able to ask you what is that number raised to the power of 1/2, and you should be able to give me the answer because you're doing the exact same thing. Okay? Okay, so let's scroll up and look at all the ones with the third. Hopefully we can do the left column without the calculator. What is 2 cubed? 4 cubed. 64. 5 cubed. 125. Okay, on the right, Alexis, will you put 8 to the power of 1/3? Maddie, will you do 64 to the power of 1/3? Jonah, will you do, and that needs to be 125 to the power of 1/3. Jonah, will you do that one? Again, if I did not say your name, I want you to pick one of those 3, and I want you to do it because you need to know how to put a rational exponent into the calculator. Maddie? 4? 2. Jonah? 5. Awesome. So, what conclusion can we draw from that table? Emily? No, that's correct. That's actually what we're going to get into down here. This kind of draws us into another conclusion that I want us to make sure that we know. But yeah, that's extremely accurate. Okay, so what I want you to know here is raising a number to the power, and we'll go ahead and just write out the explanation here. Raising a number to the nth power is the opposite of raising a number to 1 over n. Okay, so whatever this n, it was 3 on this table. That was that example. That 3 can be any number. Alright, so those are the opposites. Alright, which, if you realized, and this is kind of what Emily was saying to expand on that, raising something to the power of 1/3 is the same as cube rooting it. And on problems that we've already done, to get rid of cube root, we cubed it. So now we're just saying, okay, cube root is the same as this, so to cancel it out, I'm going to raise both sides to the power of 3. You know, if you're having to solve an equation. So coming down here, this is just a little format on how to do that. But then we're going to, on the next page, you've got kind of a diagram that explains how to go from one to the other whenever that fraction is something other than 1 over whatever. kind of stay on this page with me though. I'm going to give you a diagram, or a rough diagram, a way to remember how to write something that's in radical form and write it in rational form, and then also the other way around, which is what I had written up here on the board originally. So if I have, and make sure that, you know, it almost makes it awkward, kind of write this real big with the spacing. If I have a to the power of m over n, okay, that n can be any number. On this, the thing we just filled out is 1 over n. We're going to write that into radical form. Okay, so an easy way to think of this. Now, if you want to, the little diagram on the next page where it kind of walks you through step by step, put this here and put this here. You can do that just as, that's fine, if you want to do it that way. This helped me, and I've had some students where it's helped, so I figured I'd show it. If you can kind of think of that rational term in 3 levels, okay, each one of those, the parts of the fraction in your base, those are going to go, they're going to stay in that same level, and they're going to go directly across. Where m is now the exponent that the radical is being raised to, n, or the denominator of the fraction, is what goes in front of the radical, and a, which is your base, goes underneath the radical. And if you're given a problem that is in radical form, and you're asked to write it in rational, you can just move them back over to the left, and that puts it in rational form. One question that was a very valid question last class is, let's say the problem was this. Does that exponent go outside the radical or inside the radical? Okay. Ayla, will you write it like that, please? Or put it in your calculator like that. Lily, will you put that in the calculator like that? To get the cube root, it's math 4. And Ayla is putting it on the outside. Lily is putting it on the inside. It should be a pretty large number, probably. What did you get?
215.44.
0.44? Lily, what did you get? Does it matter where that exponent goes? No. Come test time, though, if it's multiple choice, don't get stuck that it has to look like this when maybe an answer choice looks like that. You need to know that those two are the same things. Okay? So let's go to the back, and we're going to practice writing it. Just what I will call rational to radical, radical to rational. So if I have x to the power of 3 over 4, and I want to write that in radical form, I'm just going to drag those across. So it's going to be raised to the power of 3. The 4 goes in front of the radical. The x goes underneath. Okay, so Paulina, on the next one, if I'm going from radical to rational, what's that going to look like? To the power of?
3 over 5.
Awesome. Okay. Noah, the next one, it's in rational form. I want to write it in radical. What would that be? Let's make sure that we know how to say this, and especially, well, more importantly, whenever I say it, you know what you need to be writing down. That would be the 9th root of x to the power of 5. The one above that would be the 5th root of x to the power of 3, the 4th root of the x to the power of 3. 3 questions on your homework it's in words, it has it written out, and it's just asking you to write what those words are trying to tell you. Okay, because we're not used to seeing, other than, you know, square root and cube, we're not really used to seeing those other numbers in front. AJ, what would the last one be in radical form? Rational form, sorry.
X to the power of 2.
Okay. Can I write that as x to the 5th? Yes. Same thing. Now, hopefully you didn't move ahead to this table because we are not going to use your calculator on it because we don't really need to. If I've got a negative exponent and I want to get rid of the negative exponent, where do I move it and its base? Maddie? To the denominator. So on this first one I have 1 over 2 squared. What is 2 squared? 4. So 2 to the power of negative 2 is 4. So noticing that little pattern right there where we moved everything, 4 to the power of negative 2 is going to be what? 1 over what? 1 over 16. 5 to the power of negative 2 is going to be what? 1 over 25. Now looking at these next three, now I've got 1/2. So first thing I'm going to do is I'm going to get rid of my negative by putting 2 to the power of 1/2 in the denominator. Raising something to the power of 1/2 is the same as doing what? Square rooting it. So 1 over the square root of 2. Now I'd rather you leave it like that and not give me a decimal. So what's the next one going to be?
1 over
Do what, Matthew?
1 over square root of 4.
Okay, and what is the square root of 4? 2. If it comes out to a perfect square, go ahead and take the square root of it. Okay, the square root of 2 is going to give you 1 point something, 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 something. And then the last one would be what? Okay, so before you get the homework and you freak out, okay, do not. Okay, so again, don't freak out whenever you get the homework because the homework has 27 questions. Okay, now listen. The first 6 problems, all you're doing is you're writing it either from radical to rational or rational to radical, which is the table at the top. That's all you're doing. The next 3 problems is what I was saying. It's in words and it's asking you to write it. 10 through 17, it's practice putting all this stuff in the calculator. Which one thing, we do need to talk about one thing on that. And then on the back, you're doing what we did on this last one, this last table. Okay, a little more complex, but then it's got a word problem at the end. So the front might take you 5 minutes to finish 17 problems. Now, let's talk about whenever you have this right here, how to put that in your calculator. Everybody hit Math 4, and that should give you this. Okay. You can arrow over to the left and that cursor will go over that 3 and you can change it to whatever number you want it to be. So Math 4 is how you do that, but then you just need to know that you can arrow over there and change it to whatever it needs to be.